Let's talk about standardizing a normal curve. So in the normal curve, the numbers -3, -2, -1, 0, 1, 2, and 3 are what we call the z-scores or the standard scores. So the purpose of this is to identify and describe the exact location of each score, x value, in a distribution. So a specific value of x can be transformed to a z-score or a standard score by using the formula z is equal to x minus mu over sigma, where x is the specific score, mu is the mean, sigma is the standard deviation. So let's have this example. Determine the z value for each of the following x values for a normal distribution with mean equals 16 and the standard deviation of 3. So A, x equals 12, B, x equals 8, C, x equals 22. So we're going to identify the exact location of this score in the normal distribution. So let's start with x equals 12. So let us draw the normal curve. So again, -3, -2, -1, 0, 1, 2, and 3 are what we call the z value. And we are asked to identify the exact location of the score x equals 12 in the distribution. So to do that, we need to construct a normal distribution for x values. The mean 16 is located at z equals 0. Now going to the right, we're going to add 3, and going to the left, we're going to subtract the standard deviation 3. So that is 16 plus 3 is 19, that is located at z equals 1. 19 plus 3 is 22, that is located at z equals 2. 22 plus 3 is 25, that is located at z equals 3. Now going to the left, we're going to subtract the standard deviation 3. 16 minus 3 is 13, that is located at z equals -1. 13 minus 3 is 10, that is located at z equals -2. And 10 minus 3 is 7, that is located at z equals -3. Now, x equals 12 is between 10 and 13. Or in z-scores, that is between -2 and -1. So what is the specific z value of the score 12? So using the formula, x minus the mean over the standard deviation. So our x is 12 minus 16 over 3, z is equal to -1.33. So the z value of x equals 12 is -1.33. So how about x equals 8? So the same process. So 8 is between 7 and 10. Or in z-scores, that is between -3 and -2. So there's somewhere here. So what is the z-score of x equals 8? So using the formula, x minus the mean over the standard deviation. So our x is 8 minus the mean 16 over the standard deviation. Computing this is equal to -2.67. So the z-score of x equals 8 is -2.67. Now how about x equals 22? So we know that x equals 22 is at z equals 2. So meaning the z value of x equals 22 is z equals 2. So if you want to use the formula, our x is 22 minus 16 over 3. So computing this, z is equal to 2. Now how about in the problem? A survey indicates for each trip to a supermarket, a shopper spends an average of 45 minutes with a standard deviation of 12 minutes in the store. The lengths of time spent in the store are normally distributed and are represented by the variable x. A shopper enters the store, A. Find the probability that the shopper will be in the store for each interval of time listed below. B. Interpret your answer when 200 shoppers enter the store. How many shoppers would you expect to be in the store for each interval of time listed below? So let's start with number 1, A and B. So number 1, the interval time is between 24 to 54 minutes. So the mean is 45 minutes and the standard deviation is 12 minutes. So what we're going to do is we're going to identify the z value of the score 24 and 54. So let us draw the normal curve again. So the mean is 45. So going to the right, we're going to add 12, and going to the left, we're going to subtract 12. So that is 45 plus 12 is 57, plus 12, 69, plus 12 is 81. So going to the left, we're going to subtract 12. So 45 minus 12 is 33, minus 12, 21, minus 12 is 9. So score of 24, that is between 21 and 33, or that is between negative 2 and negative 1 in the z-score. And 54, that is located between 45 and 57. Okay, so let us find the z value or the z-score of x equals 24. So using the formula, that is 24 minus 45 over 12. Computing this, the z-score of x equals 24 is negative 1.75. So the score 24 is located at z equals negative 1.75. Now for x equals 54, so our x is 54 minus 45 over 12. So computing this, the z of x equals 54 is 0.75. So the location of x equals 54 in the standard normal curve is at 0.75. So using the standard normal distribution table, we're going to identify the corresponding area of negative 1.75 and 0.75. The area of 1.75, so that is 1.7 and 5, that is 0.4599. In the area of 0.75, 0.75, that is 0.2734. Now, we need to find the area from negative 1.75 to 0.75. So that is between the score 24 and 54. So what we're going to do is we're going to add the areas of negative 1.75 and 0.75. So the area of negative 1.75 is 0.4599. Plus the area of 0.75 is 0.2734. So adding this, the sum is equal to 0.7333. So the probability that the shopper will be in the store between 24 to 54 minutes is 0.7333. Or in percent, just multiply this by 100, that is 73.33. Now, how about letter B? So how many shoppers would you expect to be in the store between 24 to 54 minutes? We need the probability. So the probability again that the shoppers will be in the store between 24 to 54 minutes is 0.7333. So what we're going to do is we're going to multiply this probability by the total number of shoppers that enter the store. So our n, so the total number of shoppers that enter the store is 200. So we're going to multiply this 0.7333 by 200. So multiplying this, the product is 146.66. Or, so round this up to the nearest whole number, that is equal to 147. So therefore, when 200 shoppers enter the store, you would expect 146.66 or 147 shoppers to be in the store between 24 and 54 minutes. So let's have the number 2. That is more than 39 minutes. So we're going to find the probability and the number of shoppers that you would expect to be in the store for more than 39 minutes. So again, same process. We need to identify the z-score of 39. So again, the mean is 45 and the standard deviation is 12. Okay? So 39, that is between 33 and 45, or negative 1 and 0. So that is somewhere here. So we need to find the exact location of this 39 in the standard normal distribution. So using the formula, so that is now our x is 39 minus the mean is 45 over 12. So computing this, the z is equal to negative 0.5. So the z-score of the score 39 is negative 0.5. So we need to find the area of negative 0.5 using the z distribution table. 0.5 or 0.50, 0.50, that is 0.1915. So that is from 0 to negative 0.5. So that is the area of z equals negative 0.5. Now, we are asked to find the probability that the shoppers will be in the store for more than 39 minutes. So meaning from negative 0.5 going to the right. So we know that half of the distribution, the area is 0.5. And this area from 0 to negative 0.5 is 0.1915. So what we're going to do is we're going to add the area of negative 0.5 and half of the distribution, which is 0.5. So we have now 0.1915 plus 0.5. The sum is equal to 0.6915. So the probability that the shoppers will be in the store for more than 39 minutes is 0.6915, or in percent that is 69.15%. So how about letter B? So how many shoppers would you expect to be in the store for more than 39 minutes? So again, we did the probability. That is 0.6915. So the total shoppers that enter the store is 200. So we're just going to multiply again the probability by the total number of shoppers that enter the store. So that is 200 times 0.6915. Computing this, the product is 138.3. So round off, so this is 138. So when 200 shoppers enter the store, you would expect 138.3, or about 138 shoppers to be in the store more than 39 minutes. Thank you.